Hello, everyone. Welcome to today's presentation from my colleague Hari Sundar Mahadevan. Today's topic is a pretty long one, and it's called Assessment of Situational Awareness in Relation to Advanced Navigation Systems Using Ship Handling Simulators. We are both team members of the team Nautical Solutions at Fraunhofer CML, and Hari also did a lot of research in that area. So before we begin, I have a few important announcements to ensure a smooth session. First, I want to thank you all for joining today. Please remember to keep your microphones muted throughout the presentation to minimize background noise. We also kindly ask you to turn off your camera as we will be starting a video recording of the session. Lastly, if you have any questions, please keep them for the end. After the presentation is done, everybody can ask the questions. Now, without further ado, I would like to hand over the floor to my colleague, who will present the assessment of situational awareness in relation to advanced navigation systems using ship handling simulators. Thank you.
Thanks, Hari. Thanks for the good introduction. So good afternoon all. Welcome to this week's Maritime Innovation Update. I'm here to present on the topic Assessment of Situational Awareness in relation to the advanced navigational systems using the ship handling simulator. So this is the agenda for today. First, I will start with the introduction. Then I will briefly describe about the situational awareness and its assessment techniques, and then briefly describe about our proposed essay assessment tool and the experiment conducted using the essay tool. Did you know that the human errors is the leading cause of maritime accidents? According to studies, as high as 75 to 96% of the maritime accidents have human error as one of its causing factor. There are various reasons why the human error occurs, like fatigue, overworking, lack of technical understanding, but the researchers have found the lack of situational awareness is a predominant cause of the human errors. As you know, digitalization and automation are revolutionizing our maritime sector. Technologies used in the maritime industry are constantly improving and evolving. The introduction of new tools such as and technologies have various advantages. For example, the use of EGDIS is one of the most consequential additions to the modern bridge. Its accurate nautical charts superimposed with the GPS or the radar data can help the officer on watch. But these tools and technologies have increased the information that is collected, processed, and depicted, making it visually and mentally complex to handle these advanced systems. So it is important to focus on the human factors and improve the situational awareness to improve the safety in the maritime sector. Moving on. So what is situational awareness? Situational awareness is just defined as having a good perception of the surroundings and the environment at all times. According to Dr. R. Mika, this situational awareness is defined as 3 levels. First is the perception, next is the comprehension, and the projection. So first, we try to build a mental picture of the environment using our hearing, voice, and vision and touch, and then create an accurate mental picture based on understanding, knowledge, and the experience. Based on this current understanding that we have got, and then we try to predict the future and take critical decisions. For the future, projections need to be accurate, the understanding and the data collected should also be accurate. There are various factors that affect this situational awareness. Like there is huge or humongous amount of data, there is poorly presented data, and there is a different form of data. As I mentioned before, stressful situations, workload fatigue, or some major factors that affect the situational awareness. And there are more than 30 different EGDIS manufacturers, and every manufacturer has a different custom option available in their EGDIS. The automated tool increases the out-of-loop syndrome, leading to lack of situational awareness and the ability to respond in case of system failure. In the domain of maritime safety, an inverse correlation exists between the SA, the situational awareness, and the scenario by the system complexity. This emphasizes the need for an effective training and assessment for improving the situational awareness. Moving on to the situational awareness assessment techniques, there are various techniques such as SAGIT or the situational awareness global, which is called as the situational awareness global assessment technique. Next is the situational awareness critical factor developed by Mr. Hogg, and there is SALSA and QUASA. These are different techniques. We use the situational awareness global assessment technique called the SAGAT for our essay assessment. It uses the freeze frame probe technique to compute the essay rating. In the freeze frame probe technique, the maneuvering task being performed by the participants on the ship simulator is frozen at a random time, and the questions pertaining to the situation are presented to assess the answers in a fixed duration of time. The responses are then recorded for evaluation and the essay score is then calculated. The freeze probe technique is used multiple times for each assessee for different scenarios and questions. The random freeze frame timing makes the SAGAT as one of the best essay assessment techniques with high correlation to the real performance. Moving on to our proposed solution. The main objective of our proposed solution is to study the effect of the ECDIS and its user interface on the situational awareness of the navigators. As I mentioned before, it is based on the SAGAT essay assessment technique, which utilizes the freeze frame probing technique. The situation of the scenario or freeze times is different for each user, resulting in different correct answers depending on the individual's navigational skills. Therefore, the correct answer must be determined by our toolbox in real time. So this is the major purpose which we have developed this essay assessment tool. So for the scenario evaluation, we try to create complex navigational scenarios and we try to pause it in different intervals. And we present a dynamic questionnaire based on the current scenarios and the participant experience. Questions are integrated with a map for context. For the communication protocol between the ship handling simulator and our essay tool, we use a distributor interactive simulation protocol for the simulated data exchange. We also implement a rule-based assessment technique to assess the adherence to the call regs, the collision regulations based on the collected data. We have our question control window and the storage, a dedicated interface to dynamically display the questions alongside the scenario map and evaluate the participant answer and store the results for analysis and feedback. So our experimental setup consists of two major components. First is the equipment bridge, which is the ship handling simulator, where we have radar, ECDIS, VHF communication, steering bar engine control, alarm, and logbook. Here we can integrate any ECDIS from the different manufacturer into our bridge. Next is our essay questioning or the essay tool, which consists of two major components. One is the question control tool, and next is a simulation control tool. And we also integrate eye tracking systems into our essay tool. So this is the basic description of our situational awareness tool. So here in the map, as you could see, we have our tracker application, which collects the data, which decodes the data from the disk PDU packets, and we track all the objects using our callreg based tool-based assessment. And we have the user map interface, which we try to integrate with the electronic nautical charts for context. So this is our question control tool. This question control tool is used to load the dynamic questionnaire onto the interactive map based on the current scenario and the participant experience. So at first, the participants can be selected. As you see here, based on no voice or expert, we can select the participant number is selected. And based on this participant selection, the scenario stimulus order for different combination of scenario and the freeze times will be loaded in this question control tool. And then we try to and then we can stop this scenario at any instance. So we have three type of questions, that is single choice, multiple choice, and short text type questions, which is integrated into our question control tool. Next, moving on is our simulation control tool. This tool automates the process of scenario start, stop, bar freeze on the ship handling simulator based on the selected participants. The tool assigns a predefined stimulus order for the scenarios, number, and the time of freezes for each participants, and load the scenarios into the SHS for assessment. Moving on to our experiment conducted, a total of 7 complex navigational scenarios and maneuvering scenarios with varying difficulty levels and duration and number of freezes or design for the assessment for the test participants. A total of 40 subjects or the participants were divided into two groups, like 20 novice and 20 experts. This 20 novice were like nautical students with with prior knowledge in radar or ECDIS technologies, whereas the expert group consisting of at least 5 years of professional navigation experience. So the coordination of this complex individual tasks steps for participants and the interaction to the SHS tool were like entirely successful, and the feedback from the participant also showed that the entire experiment setup was successful. Moving on to a flow diagram of our hypothesis testing. First, we try to create the complex navigational scenarios. Then our simulator is powered on. Then our simulation control tool and the SA tool is also started in a laptop. The participant IDs is selected in both of our applications. Then our simulation control tool loads the scenario onto the SHS, and then we start the maneuvering of the participants. Our simulation control tool automatically freezes at the distinct time in the SHS and the participant. Now, from our question control tool, the questions are like propped in the map with context, and then the participant answer these questions, and based on this, and then we try to store the results and we do the SA assessments. After the freeze is then elapsed, then once again the maneuvering participant starts the maneuvering task, and this is done for all the 7 scenarios, and almost all scenarios have at least 2 to 3 freezes. So the basic our hypothesis testing creates realistic scenarios, and there is no repetition in. So there is a repetition in the training. So enhancements of operators' ability to recognize and respond to different situations effectively. This is a risk-free training, as you know, and we get the immediate feedback, and we can customize the scenario for various things. Now I would like to conclude by saying that this experiment setup was successful. The proposed tool developed and evaluated for the ECDIS-based training situational awareness assessment shown a good promise. In our future research avenues, we try to integrate some machine learning techniques for scenario generation and situational evaluation. The evaluation and measurements of transparent users SA is especially helpful in terms of like developing some complex navigational systems, and enables manufacturers of such systems and designs in their next projects. And we have also examined 2 factors like scenario type and navigational experience on the situational awareness, and the mental load and scenario difficulty. And if you want more details about this, about the results, I would share our paper, which we have presented in one of our conference in the chat. Thank you.
All right, Harry, thank you for your insightful presentation. Now I will open the gates for the questions, if there are any. You can either raise your hand in the chat and speak directly, or you can ask your question in the chat. To bridge the gap, I have a little question here. Could you elaborate, please, on how findings from your assessment can be applied to improve training programs for maritime operators?
Yes. So like we have, as I mentioned before, we are trying to examine like 2 factors. One is the scenario type and the navigational experience, on the situational awareness and the mental load and scenario difficulty. So this kind of examinations, like this kind of plots that we try to develop, will be useful for how we can train the navigational persons with some various scenario types, I would say. And also this will also be, as I mentioned in my last point, like this is more useful for when we try to develop our complex navigational systems, like such as ECDIS or radar systems. So for this assessment would be much more helpful. I think we also designed our own kind of an UI, like kind of an ECDIS based UI, which we also try to evaluate that UI with the current ECDIS things. So this could be more this evaluation will be more useful in that terms.
Thank you. So are there any other questions? Or maybe you answered all the questions during your presentation, so who knows? I will wait a little bit. I'll give you 10 more seconds. Okay, no questions. Seem like you have done a great job, Harry. So I would like to conclude this presentation for this week. Thank you for being here. See you all on next Friday.